The viewers, now we discuss important topic Cauchy-Riemann equations. At first, let us consider the functions fz and which have two component functions u and v, and the first order derivatives of the component function uv is a function of fz is equal to u xy plus iv xy. Taking it equation number 1, which satisfies at a point z0 is equal to x0 y0 and all are complex valued function when the derivative of f exists and both u and v functions possesses first order partial derivative. Now f dash z, suppose the derivative, then the derivative of fx, that is f dash z0, derivative at the point z0 is equal to, by definition, limit del z tends to 0 f of z0 plus del z minus f of z0 by del z. Taking it equation number 2, and which exist. Now z0 is equal to x0 plus iy0, we are writing this, and del z equals to del x plus I del y. We already know that z is a function of x plus iy. Now we consider the expressions, the following expression: real part of f dash z0, and that will be given by limit as both del x del y tends to 0 0, real part of f of z0 plus del z minus f of z0 by del z. Taking it equation number 3, and imaginary part of f dash z0 is equal to limit as del x del y tends to 0 0, imaginary of f of z0 plus del z minus f of z0 by del z. Taking it equation number 4. Now where the expression f of z0 plus del z minus f of z0 by del z, that will be given by u is the function of, we simply consider here the earliest equations. Number 1, f of z0 plus del z0. So variation will be applied on x and y. So z0 plus del z will be given by u of x0 plus del x comma y0 plus del y minus u of x0 y0 plus I v of x0 plus del x y0 plus del y minus v of x0 y0. And here in the under situations, del z can be written as del x plus I del y. Here also we write same thing, del x plus I del y. So we complete these two things. Now these two equations, and equation number 3 and 4, real and imaginary part, this 3 and 4 equation valid as del xy tends to 0 0, and we may choose the expression three and 4 is valid as del x del y tends to 0 0. Now we have to choose in particular cases. We are taking horizontal and one other taking vertical. Now let del x del y tends to 0 0 horizontally. Through the point del x 0. What happens there? And vertically through the point 0 del y. We have here one cases in the horizontal cases, that is real part of f dash z0. Simply we write limit del x tends to 0 because y component is already vanished. U of x0 plus del x and y0 del y vanish minus u of x0 y0 by del x, and imaginary component f dash z0 for the second cases limit as del x tends to 0 v of x0 plus del x comma y0 minus v of x0 y0 by del x. So we have getting real part and imaginary part. Therefore f dash of z0 that will be, by first definitions, it's a definition of partial derivative, del u del x or ux, it can be written as del u del x at x0 y0 plus real part plus imaginary part. So it will be I into, imaginary means I into vx of x0 y0. We are getting this result. It is the first cases when we are taking the point del x comma 0. It is a horizontal cases. For horizontally through the point del x comma 0. Now we consider the vertical cases. Then here we considering the point 0 comma del y. We have for next cases that is vertically through the point 0 del y. We have real f dash z0 is equal to limit del y tends to 0 u of del x component 0, so x0 comma y0 plus del y minus u of x0 y0 divided by I del y, because real part is 0. And for the next cases, that is imaginary of f dash z0 limit del y tends to 0 v of x0 y0 plus del y0 minus v of x0 y0 by I del y0. And it is obvious result. It's a part of imaginary. So we have f dash of z0, that is a case of real part, so it will be 1 by I uy of, that is del u del y x0 y0 plus, that's a part of imaginary, so I will be there and cancel, that is a vy of x0 y0. So if we are simply taking minus I, this was I square minus 1 uy of x0 y0 and minus I square vy of x0 y0, we can get minus of I uy x0 y0 and plus I into vy of x0 y0. Okay, and now it can be written as minus of I uy plus simply written as uy of x0 y0 and plus vy of x0 y0. Finally we write in this manner. Now for the next stages we are getting both the type of equations, and here if we name this equation number 5, and here also naming the equation number 6. So we have equating both f dash 0 from 5 and 6. So from 5 and 6 we have that is f dash 0. So ux x0 y0 plus ivx x0 y0 is equal to minus of iui x0 y0 plus vy x0 y0. Now equating real and imaginary part, we get ux x0 y0, that will be taking is the real part, equal ux equals to vy of x0 y0 and taking it equation number 7, and vx x0 y0 is equal to minus uy of x0 y0, taking it equation number 8. So the equations 7 and 8 are called Cauchy-Riemann equation, or in shortly shear equation. So ux equals to vy and vx equals to minus uy is called Cauchy-Riemann equations or shear equations, and it is a very important equations for complex analysis. Now we end our discussion. If you like this video, like it, share it and subscribe the channel. Thanks for watching.